Good afternoon and welcome to the GibbsCAM Multitask Machining webinar. If you have any questions, please save them till the end and we'll take a Q&A session. Today we're going to be talking about GibbsCAM Multitask Machining, and this webinar is specifically designed to aid shops who are looking for software to program their MTM machines, multitask machines. In the next 30 minutes, we will answer common questions that you may have when starting into MTM, and we will show the ease in which GibbsCAM can set up, program, and even simulate your complete process. As you can see here on the GibbsCAM screen, we have a multi-spindle, multi-turret MTM machine, but we're going to start a little bit further back than that, and we're going to start with MTM level 1. In this 30-minute session, we're going to be talking about the different levels of multitask machining. And here we're going to start with MTM level 1, which is a machine with 2 spindles and 1 turret. Let's watch this part program run, and let's talk about questions that you might have as a GibbsCAM user looking to get into multitask machining. The first question that you might have in your head is, how easy will it be to program my new complex machines? As you can see here over on the right, we have an operations list that looks pretty standard for GibbsCAM. So let's get right into it, and let's first have a look at how we would create a toolpath on an MTM machine versus a standard turning machine. On a standard turning machine, we have tools, a tool list, and we have operations over here, and it looks exactly the same in MTM. This tool faces the main spindle. This one also faces the main spindle. This one faces the sub-spindle. We have a front face drill, an OD drill, a parting tool, and a rear face drill. Let's look at how these tools may differ from your standard GibbsCAM to an MTM style machine. The first thing you will note is that you have the ability to select the turret position, and if there is a second turret, we'll show in the next file how you can select the upper turret or the lower turret. You'll also see on the multi-quad tool holders, we get to select the position of the tool. And we also have a new button over here that says cut X plus or X minus, since the upper turret will cut on the plus side of X and the lower turret will cut on the minus side of X. Let's go look at the drilling tools for the front face. And yes, their orientation is pointed left. It's in turret position 3. Since this machine only has 1 turret, you can see there is no turret selection. So let's talk about how to put a toolpath on a part, the mechanisms of GibbsCAM for those of you who may not be familiar. We combine a tool with a process from the machining toolbox, in this case rough, and we set our roughing parameters. If you're familiar with GibbsCAM, you will notice that this menu looks almost identical except for 2 things. Here we have a part station selection where we can select the main spindle or the sub spindle. And then down here in the bottom of the window, we have to select the machining coordinate system. So let's take just a moment and talk about machining coordinate systems. Your standard lathe would have a ZX plane, an XY plane, and an XZ plane, corresponding with the 3 planes that are required to run your MTM machine, G17, G18, and G19 plane. But on this machine, which has 2 spindles, automatically when you start up the file, you will get 6 coordinate systems: ZX plane subspindle, XY plane, and YZ plane subspindle. It's easy to remember about the coordinate systems in that ZX plane is for turning, XY plane is for front milling, and YZ plane is for OD milling. So let's look at how to create a GibbsCAM process from scratch. We have the process window, OD, forward. We're not going to cut other side because this is an X plus side. feed, speed, depth of cut, rough stock diameter, main spindle, stock, rapid step, and we would select the geometry using the profiler, because when you bring in a solid model into GibbsCAM, you do not have to extract geometry. Simply turn on the profiler and we're going to point our machining markers at the surfaces that we want to cut, and we're going to press do it, and as you can see, we get a tool path. Now, we're not going to cover the contour tool path because we want to step right into the drilling tool path. And now, since we have an MTM machine and we're drilling on the XY plane because this is a live tool drill in a bolt circle, we're going to be on XY plane front spindle. Here on the process tab, on the holes process tab, we do select the XY plane front spindle. And since this machine has limited y-axis reach, we're going to use polar and cylindrical milling so that Gibbs will rotate the part, and we only have to select one hole and duplicate it 3 times at 90 degrees. Go back to the drill tab, and part station is main spindle. We select one hole, press do it, and we have a tool path. The same thing for the next operation, operation 4, except it's on the YZ plane. Notice that when we double click a completed operation, the YZ plane automatically highlights, the profiler automatically opens up, and the geometry that was originally selected gets highlighted again. So let's have a quick look at this operation. Rotate tab, YZ plane, duplicate 3 at 90, main spindle, and remember that when we are working on live tool in the YZ plane, we are working on the radius. This is a 2-inch diameter part. So here, this operation looks just like any other operation, but we want to cover one more thing before we go back to the simulation. Something that's different about MTM is that we have control over the non-cutting aspects of your machine. And that's your big question right now is, how can I control the non-cutting aspects of my machine? A parts catcher, a bar feeder, a sub-spindle, or a steady or a follower rest. When you receive a machine-ready package from GibbsCAM, in that package will be a VMM file called a virtual machine module. And what it does is it allows you to operate these utility ops. And on your machine, you may have these utility ops or more or less. On this particular machine, look at all the utility ops that we have available here. So in this utility op, this is going to be a sub-spindle in. So this is how we control the sub-spindle, how it moves, the RPM that it moves, whether we synchronize the front and rear spindle together. The part is in the main, it's not in the sub. We're going to wrap it within this distance before we feed onto the part, and we get to specify our grip Z. Once we press do it, we have a utility op that brings the sub-spindle in. Then we will do a part off operation, and then another utility op that allows the sub-spindle to return home. So again, utility operations are what allow us to control the non-cutting aspects of your machine. Let's watch this part run one more time so that you can see all the things that we've covered, and you can also see that this quad tool holder is automatically commanded to move in the y-axis by GibbsCAM because GibbsCAM understands where each of those 4 tool tips are. As soon as the part file is done running, I will show you how we identify the tooltip position. And here, we're going to go back to rewind, and the top of the program, if we click on Tool 1 and force a redraw, Tool 1 is highlighted in yellow, and so on, and so on, and so on. Let's add another utility op to this program very quickly, and we're going to do a parts catcher drop. So let's double click the utility op. We're going to parts catcher in, to the main spindle, do it. We're going to create another utility op, which is unload spindle to the parts catcher, main spindle, do it. And then finally, parts catcher return from the main spindle. And the spindle is unloaded. So there we created utility ops. And now when we go back to the beginning of the program and rewind, you'll see that the parts catcher drop will happen and the part will be gone at the end of the program. So utility ops are very, very simple to work with. So this covers MTM level 1. Let's talk about MTM level 2. We're going to step to a dual flow machine, and we're going to talk about now the machine definition dialog and what a dual flow machine is. This is a two-flow machine or a dual flow machine. It's a Morisaki NZX 2000. It has 2 turrets and 2 spindles. And we can control all of the synchronizations between the upper and the lower turrets to make sure they don't crash into each other. But let's have a look at the machine definition dialog. And the question that you have is, do I really need machine simulation to avoid crashes and shorten my setup and programming time? And we're going to answer that question in the next few frames. We have here in this particular machine, the synchronization control. This is what allows us to synchronize the upper and lower spindles so that number 1, they work together, and number 2, they don't crash into each other. In this case, we have told op2, which is the second spindle, to wait until op1 is done. The synchronization control is very simple to read and understand. If you look at the synchronization control, you'll see that flow 1 or turret 1 is on the left and flow 2 or turret 2 is on the right. This would be operation 1, operation 2, operation 3, 4, 5, 6, and 7. And we have the ability to coordinate those operations together. We have a sync here at the beginning of the program that tells op2 to wait until op1 is done. We're going to ruin that, and we're going to use the program checker to tell us if everything is okay or not. I'm going to ruin it by removing the synchronization between ops1 and ops2. If we don't have a synchronization between op1 and op2, we now have 2 tools calling for the same spindle direction at the same time. While we don't have a crash situation, we do have a situation to where those tools, because both inserts are facing up, are fighting for control over the spindle, and that's not going to work for us. So we're going to stop the simulation. We're going to put the synchronization back in and tell op2, the top of op2, to wait until the end of op1 to do its job. And we use the program checker to tell us that all checks have passed. We'll do a quick run back to the beginning of the program. And we'll see that now everything is okay. We need to do one more task, and that is we're going to create an actual crash so you can see what crash detection looks like inside of GibbsCAM. We are going to remove the synchronization between ops 3 and 4, which are on opposing turrets, but are both trying to drill holes in the front face of the part, and you will now see a crash with crash detection turned on, and GibbsCAM will tell us that we have made a mistake before we send this out to the floor. So we are protecting your investment, we're protecting your equipment, and we are crash proofing your machines. Here comes the drill, and they're together, and now we have a crash situation, and the clash gouge console on the right actually told us what hit what at which operation and where to go to fix it. So what do? We go back to our synchronization manager, and we add the sync between ops 3 and ops 4. We go back and refresh the program error checker, and everybody's happy again. We're going to run this through again, and while it's running through, we are going to talk about the machine definition dialog. Now that we've covered how to control a multi-spindle, multi-turret machine, we're going to talk about document control and the machine definition. Each machine has a definition file that sets up GibbsCAM's interface that works exactly for that machine. So you only see this machine's attachments, spindles, and turrets. Here we see a main spindle and a sub-spindle, and an upper turret and a lower turret. No additional information is required to program your machine. So again, this machine definition dialog here sets the interface up so that you are programming your machine exactly, and you don't have too much information to look at or too little information to look at. So let's look at main spindle and sub-spindle stock setup. Since you are familiar right now with 3-axis mill and 2-axis lathe, you're familiar with the stock setup: diameter, front face, rear face. But notice, since we are using intermediate tooling and the collet chuck, it tells us that the collet chuck's length is 5.507, and we told it that we want the part hanging out 4 inches from the front, and that the main spindle is initial stock and preloaded. Notice that each spindle has its own parameters. Let's go look at the sub-spindle parameters. It has no parameters because we said initial stock is not here. We're going to pass it off from the main spindle. The only thing that we need to tell it what to do is how far is the part going to be hanging out of the spindle after the pickoff. The pickoff that we demonstrated in the first part file. So we're done with the pickoff, and we have the part in the sub-spindle, and now the stock is in the sub-spindle, as you can see at the end of the program. So again, the machine definition sets up GibbsCAM for your exact machine. And let's go to another machine tool that is another MTM single flow. But again, we want to look at this particular machine and how it works. And we want to go back and look at the MDD and see how it differs for this type of machine. This is a single turret, twin spindle machine. And in this file, we want to look at the MDD very quickly. It has a main spindle and a sub-spindle, but only one turret. We've talked about the main spindle and sub-spindle setup, but let's talk about, just for a moment, intermediate tooling. Your chucks and tool holders become a part of your machine simulation. And machine simulation requires very little effort on your part to set up and to show everything running correctly on the part. For instance, when we want to select a chuck, we simply go to the Intermediate Tooling tab, go to Fixture, and select our chuck from a list of chucks that are available for the main spindle and a list of chucks that are available for the sub-spindle. And in this case, the chuck is actually interactive with the diameter of the stock that we typed in here. You change the diameter of the stock, it changes the grab diameter of the spindle. Let's go and look at intermediate tooling from a tooling side, and we have this tool. It has an intermediate tool, again, that comes from the intermediate tooling list on the tool attach page, and you get to select your tool holder from a list of tools that are available. Again, it's very fast, it's very effortless, and it doesn't require much time on your part at all. So we looked at the MDD, we looked at the speed of the setup, and the time savings of programming and simulating offline. The fact that your machine is not tied up out on the floor while you single block through a program, GibbsCAM gives you the confidence that you need to be able to post a program and send it right out to the floor. We're going to start talking about MTM level 3 now, and we're going to step up to a very simple star machine. And the question that you have right now is, what if I have a machine that is a non-standard? And by the way, MTM machines have not been standardized. There's no such thing as a standard MTM machine, and GibbsCAM has the flexibility to be able to work with all types of machines, no matter how many flows. Here we have a 2-flow Swiss machine, and we just wanted to show you how it operates. But another interesting tip that we want to show you is when you are setting up a complex machine like this, we have this little indicator called the show position indicator. The show position indicator lets us test our setup and our tools and our axis to make sure that we have everything set up like we need it. All the tools can reach the part and all the parts can reach the individual spindles. Again, saving a tremendous amount of time of your setup time in the day so that you don't have to do this out on the floor. And you can actually send a picture out to the floor to the setup man so he'll know exactly where to put the tools into the machine. Let's step it up a little bit and let's go to a more complex multi-flow Swiss style machine. And this is a Citizen L220. And we're going to look at this in our dual window so that we can zoom in on certain parts of the program so that we can simulate it quickly, check for errors, and look at it at any angle that we want. Let's zoom in on the main spindle on this one. And here, let's zoom in on the sub spindle so we can see everything that's going on there. This is a multi-flow machine. And your question is GibbsCAM flexible enough to cover all of my MTM types? And the answer is yes. GibbsCAM can cover single flow machines, 2-flow machines, 3-flow machines. As a matter of fact, we can handle up to unlimited spindles and unlimited axes. So we have the ability to build a special machine just for you. And here in the Swiss, we use the same methods that we used in the other machines, except Swiss has a unique benefit in that when we go to the sync manager, you'll notice that inside of the sync manager, we have light blue system syncs. Light blue system syncs are automatically generated by GibbsCAM when we are operating a Swiss multitask machine. And as you can see, the Swiss machine, even though this is a very complex part, required no operator generated synchronization because all of it was done automatically with system syncs without a crash on this machine. So while we're here, we're going to talk about Swiss machines and how they differ from other machines. Because they are multi-flow machines, they are multimodal, and they have different machine modes. As you can see here, we have G630 mode. And let's go down the list and we might see some other modes. But let's open up one of the operations that has a utility op in it, and let's see what modes are available in this particular Citizen style machine. It has pattern cancel, single machining, ID/OD simultaneous machining, parallel machining, front and back simultaneous machining, and rear machining only. So each Swiss machine, again, has its own utility ops that allow us to do special things with Swiss machines. Another benefit of Swiss machines is that we have this new cutoff part transfer op, which is a single operation that does everything for us. It does the sub spindle in, it does the cutoff, we tell it where the cutoff Z is, the return, and the speeds and feeds at which we return. And that is a cutoff part transfer. Automatically, when we do a cutoff part transfer, you will see that the appropriate axes physically get out of the way so that the sub spindle can come in, the parting tool can do its job, and nobody has any collisions. Again, this is a function of MTM level 3. So MTM level 1 was a single flow machine. MTM level 2 was a dual flow machine. And MTM level 3 could be 3 or more flows. and they're not treated any differently. So if you can program a 2-flow machine, you can program a 5-flow machine. The Swiss machines also come in many different flavors. There are Swiss chuckers, and Swiss machines are now approaching another stage in which they have decided to go back to turrets on certain types of machines. The ECAS machines had a turret, and now Tsugami machines have a third generation of Tsugami machines that have a turret on it, where this is a gang style machine with a B-axis. So here's another thing. We have taken the gang tools and we have now added a B-axis to this particular machine. Let me rewind it and slow it down a little bit at the front of the program so that you can see the B-axis turn. So this is another type of Swiss machine altogether, is a B-axis Swiss machine. We hope that you have gotten enough information to be able to make a reasonable guess as to what type of CNC machine that you will need and what type of GibbsCAM programming software that you will need to work on your parts. We would like to now open the floor to questions, and Mr. Bart Ellers is going to help us with those questions. But before we go, GibbsCAM is efficient, safe, fast, accurate, and flexible, and these machines are complex, but GibbsCAM offers a simple solution for all of your MTM needs. Mr. Bart Ellers, do you have any questions from the floor?
Excuse me. Hey, Patrick. Great job with the presentation. We do have a few questions. The first one is, are solids required for MTM?
The question is, are solids required for MTM? Solids are not required for MTM, but they are highly recommended because, as we demonstrated in this webinar, there's a lot more going on than just the interactions between the tool and the part. Here in this Swiss machine, you can see that we have tool holders, we have spindles, we have collet nuts, we have nuts and bolts and screws and parts catchers, and those are the kind of things that we need to show solids. And again, GibbsCAM will deliver to you a machine-ready package, and all you do is plug in your tool paths and your tools, and you're ready to go.
You know, I would add to that by having solids, it does significantly reduce your programming time. Solids just helps make programming faster. And overall, solids just gives you a better programming experience than trying to visualize something which is 2D geometry. Another question we have is, what is the difference between the VMM and the MDD?
All right, let's talk about the MDD. When you get a machine sim package, what's going to come in that machine-ready package? And by the way, the package is a self-installer. You simply drag and drop it onto your GibbsCAM interface. And if you go to our YouTube channel, you will see a tech tip on how to install a post package to your computer. So the first thing that you will get is a custom MDD. And while we're here, let's have a look at the Swiss MDD. It has a guide bushing instead of a chuck. Not only does it have a guide bushing, but it has a checkbox here that we can check the guide bushing if we accidentally drag the part backwards out of the guide bushing, because it may catch when we're dragging it through. So the first thing that comes in your machine package is your machine definition dialog. It sets up your interface and it controls the behavior of the machine. Now let's talk about the VMM. What the VMM does, if we right-click here in the process list and we click Change Process and go to the machining toolbox, you will see in the utility area a button that says VMM, which stands for Virtual Machine Module. The Virtual Machine Module is one of the things that sets GibbsCAM apart from our competitors and allows us to control the non-cutting aspects of your machine. In this case, not only just parts catchers and bar feeders, but machine modes and parking areas, moving tool groups from one spindle to another. We can do multiple part shifts. You have a part that's 3 feet long and we want to turn it in 2-inch sections. We can pull it out 2 inches at a time and turn it. using the part shift inside of the VMM. And each VMM is specific to your machine type, whether you have 1, 2, 3, 4 turrets. You may even have 2 parts catchers. You may even have a double bar feeder if you have an MC420 plus. So does that answer your question? And did you have anything else that you would like to add about what comes in a machine package? Oh yes, and a post processor and the machine sim model also come in the package.
I think you covered that well. Like you said, the machine, we're going to send them a package, and in that package, it'll be a machine-ready package. I mean, drag it and drop it. It's going to self-install the post, the MDD, the VMM, and even a sample part for them. But the VMM is very critical, and it's part of what makes GibbsCAM, differentiates GibbsCAMs from other CAM packages in our ability to control graphically control the non-cutting motion of a machine. This becomes very important in these MTM machines, where, as you already said, there's a lot of motion going on in these machines besides just the tool that's cutting on the part. A couple more questions, and then we'll go from there. One person wants to know, are we able to download the 3D tooling, nuts, collets, and etc. from Gibbs for our machine? So basically, they're asking about how do they build a machine sim model, and where do they get the components?
Machine simulation, once you purchase the machine simulation option, you have 2 ways of getting a machine simulation model. Number one, you can purchase it from us. We will build it for you. We will set up the MDD, the VMM, and the post processor to match your machine simulation model. Or number two, yes, GibbsCAM is fully self-contained when it comes to machine simulation. You may draw your own machine inside of GibbsCAM, and you may follow the machine simulation manual included in all GibbsCAM installations, and you may build and animate your own machine sim model inside of GibbsCAM. You may need some help, though, with the non-cutting aspects of your machine sim if you want to control a parts catcher, a bar feeder, a steady rest, or a follower rest. And by the way, we have another part file running because we wanted to show you how MTM has evolved. And as you can see, turret machines are not going away, but we're starting to see less and less turret style machines and more machines like this DCG from DMG Morisaki, where it's no longer an upper and a lower turret slant bed machine, because we found that the flexibility simply wasn't there. So they basically welded a milling machine together with a lathe, and now we have large amounts of Y-axis, and we have a built-in B-axis, C-axis, and sometimes an A-axis. So yes, machine sim is an integral part of GibbsCAM, and you may build your own machine sim model and animate it.
So I would just add to that, you're absolutely right. You boil it down to there's 2 ways once you have the machine simulation software, the option to actually do simulation, the matter of getting the model, and there's 2 ways to get the model. You can have us do it for you, in which we work with the machine tool builders to get these models, and we turn them into the dynamic model, or you can do it yourself in
Bart, your audio just dropped out. Are you still there?
Can you hear me?
Yep, got you now.
Okay, thanks. But as far as getting individual components for these machine sim models, like the nuts and the collets and stuff like that, generally Gibbs doesn't have a library of those, but generally speaking, your vendors, your suppliers have 3D models that you can get from them. All right, one last question. Can MTM support more than 3 flows?
Yes, GibbsCAM multitask machining can support more than 2 or 3 flows. The GibbsCAM framework allows us to set up as many axes, linear and rotary axes, as possible. I'm sorry I don't have the one up on the screen, but I can't show it because we developed it for one of our defense contractors, but we developed a machine sim model for a 12-axis horizontal machine, and we were able to show collision detection and very easy programming between all 12 axes of the machine without any conflict. And we did it with full machine simulation. So yes, we can do multiple flow machines and even non-standard machines. If you're familiar with Willem and McCodle, they will build a CNC machine to whatever specification that you want. And then once we at GibbsCAM see that, we can build one that will match that machine's. This is what we call kinematics, the movements of the machine, the axes, the locations, and what they can do. Mr. Ellers?
That's it. Yep. Can you hear me okay, Patrick?
I certainly can.
Okay. Well, that's it for questions right now. There were a couple more, much more technical questions, which I'm going to say I'm going to have our resellers reach out to these people individually and answer these rather in-depth technical questions because they might want to actually get into a demonstration of it. So with that said, I would say we can wrap the webinar up.
Thank you very much, everyone. And remember, GibbsCAM is efficient, safe, fast, accurate, and flexible enough for you to use in your shop on your MTM machines. Thank you so much for attending.